Bridge cranes are mounted on parallel rails attached to elevated wall structures. The bridge is a beam that runs between the two rails. A trolley with a hoist mechanism travels back and forth on the bridge. Rigging refers to any equipment used to attach a load to the crane's hook. Slings are the most common type of rigging. They support a load by wrapping around it or by connecting to it. Rigging is a very important part of safe crane operations. Unsafe rigging can cause unstable or falling loads, which can lead to equipment damage and worker injury. A properly rigged load is well within the equipment's load capacity, is stable and secure, and presents minimal danger to equipment or personnel. Safe rigging depends on these primary factors. The type of sling. The choice of sling is based on the attributes of the sling material. The type of hitch. The hitch is the way a sling attaches to a load. The sling angle. The sling angle refers to how spread apart the sling legs are. The lower the angle of the sling legs, the less the sling can hold. The load edge sharpness. The corners of a load can weaken or break a sling. The load capacity. The load capacity refers to how much the rigging is able to lift. And, finally, the stability of the load. The load should be secure in the rigging and not in danger of shifting or falling. These factors will be discussed more in depth in the following sections. Slings are the most common type of rigging equipment. Slings support the load, spread out the load weight, and make the load more stable and balanced. Slings can be made of many different materials and designed in many different ways. The four primary materials slings can be constructed of are wire rope, chain, metal mesh, and synthetic fiber. The following sections will describe these materials in more detail. Wire rope is the most commonly used sling material because of its combination of high strength and flexibility. Without wire rope, it would be impossible to perform most hoisting operations. Wire rope is typically composed of multiple metal strands twisted together. These strands are composed of smaller metal wires. At the center of the metal strands is usually a metal or fiber core. Chains are used for their great strength, for their ability to withstand high heat, and for their ability to adapt to the shape of a load. One disadvantage of chains is that they can be damaged by sudden shocks. Also, chains are only as strong as their weakest link. Both of these points are reasons why inspection of chains is very important. The most commonly used synthetic fiber slings are made of nylon, polypropylene, or polyester. Because of their softness, synthetic slings are the best choice for use on expensive loads, highly finished parts, fragile parts, and delicate equipment. Even more than metal mesh, synthetic fiber slings adhere to the contours of a load. They also have good shock absorbency, unlike chains and wire ropes. The disadvantage of synthetic slings is that they are more susceptible to damage. For example, they are not as temperature resistant as metal slings, and they are not resistant to corrosive substances. There are four basic types of hitches: the vertical hitch, the bridle hitch, the choker hitch, and the basket hitch. The following sections will describe these hitches in more detail. The vertical hitch is the most straightforward hitch. It connects directly from the load block to the load. This type of hitch is best used with a shackle attached to an eye bolt or lifting eye. A vertical hitch should not be used for lifting loose materials or loads that are difficult to balance. The bridle hitch is composed of two or more sling legs that connect directly to the load. The bridle hitch provides load stability because the load weight can be distributed evenly among the legs. and because the hook is directly over the load's center of gravity. One important note about bridle hitches. In configurations with 3 or 4 sling legs, 2 of the legs might end up supporting the majority of the load's weight. To protect against this, the load capacity of only 2 of the legs should be enough to support the entire load. The most important factor when using a sling is the sling angle. A sling can lift the most when the sling legs are closest to vertical and the sling angle is near 90 degrees. The smaller the sling angle gets, the smaller the sling's load capacity gets. The closer to horizontal the sling legs get, the more stress is put on the sling. This is easy to see with a real-world example. Which of the following 2 tasks would be easier? Holding 2 buckets with your arms down at your side, or holding the buckets with your arms straight out? It's easier when your arms are straight down because your arms have a greater lifting capacity when the load's center of gravity is beneath the lifting force. It is the same with a sling. A 1-ton load can produce several tons of stress on each sling arm at a low sling angle. This is why spreader and lifting beams are used for longer loads. They make the sling legs more vertical. The sharpness of a load edge is another important factor in rigging. The edges do not have to be very sharp in order to be a hazard. Any corner that a sling travels over creates increased tension at that point. Materials, called softeners, can be placed between the load and the sling to lessen the stress on the sling. Examples of softeners include specialized corner protectors and even just simple wooden blocks. A rigging component that bends a wire rope too sharply creates the same hazard as a sharp edge does. An example of this would be a small hook with a large diameter wire rope. If the rope bends too much, it creates stress. Devices called thimbles are used to make a gentler curve in the wire rope. The center of gravity is the point around which an object's weight is evenly distributed. To have a balanced load, the lifting hook must be directly above the center of gravity. The center of gravity may not be located directly in the center of the load. For off-centered loads to hang level, the heavier side will require a shorter sling leg. Rigging the load below the center of gravity can result in a very unstable load that could shift suddenly. The load's attachment points must be above the load's center of gravity. There are many types of hardware components used to aid the rigging and lifting process. Examples of hardware are shackles, eye bolts, and turnbuckles. The proper use of hardware components requires extensive rigging knowledge. Operators and riggers must be trained in the specific kind of hardware being used. All rigging components must be inspected before being used. If problems are noticed, the rigging should be rejected and should not be used. When in doubt about whether rigging is safe to use, talk to your supervisor. The following sections will describe how to inspect the more common rigging components. All wire rope should be inspected visually before use. Common problems with wire rope include broken strands. Broken strands can be spotted visually or detected by running a cloth over the surface to find snags. Wear. If the diameter of the rope has been reduced by more than 10%, the rope should be rejected. Heat damage. If the wire rope has come in contact with high temperature, check for heat damage in the form of discoloration or melting. Kinking. Kinks greatly reduce a rope's load capacity. Bird caging. This is when the rope strands have become separated, creating a bird cage effect. Bird caging greatly weakens a rope. Knots. Knots greatly weaken a rope. When in doubt about the safety of a wire rope, talk to a supervisor. Chains must be inspected for problems before use. Chain problems include broken links, bent links, stretched links, heat damage, corrosion, links with excessive wear, and cracked links. Also, chain slings should never be used if the chains are twisted or knotted. Hooks must be inspected for problems before use. Common problems with hooks include heat damage, wear exceeding 10% of the original dimension, cracks, nicks, or gouges. Throat opening is stretched open more than 5% of its normal dimension, and it should never exceed 1/4 inch more than its normal dimension. Hook is twisted more than 10 degrees from a straight-on view, or a malfunctioning hook latch. It is important to store rigging in its assigned storage location. Leaving the rigging in improper locations can lead to rusting, corrosion, and other damage. Here are some rigging storage rules. Never store rigging on the floor. Never store rigging in wet or damp environments. Limit exposure to very hot or very cold temperatures. Limit exposure to corrosive chemicals. And do not store synthetic fiber rigging in direct sunlight. Industrial overhead cranes have controllers that give the operator control of all of the crane movements: bridge travel, trolley travel, and hoist raise and lower. A pendant control requires the operator to walk with the load as it travels along the bridge. There are 3 things that must be verified before a lift is attempted. The crane and rigging must have been inspected. The crane and rigging must have enough capacity to lift the load, and the load and rigging must be stable. Check out the intended path of the load. Make sure it is clear of personnel and any obstacles such as debris, vehicles, or other equipment that might block the load's movement. Don't just look on the floor. Look up, too. There may be obstacles blocking the movement of the crane bridge that might not be obvious. A test of the crane's movements must be performed. The primary movements for most cranes are bridge movement in both directions, trolley movement in both directions, and hoist movement, raise and lower. Verify that the crane operates correctly, with no problems. When running the crane, look for unusual movement and listen for unusual noise that could indicate a problem. Also, test the brakes and the emergency stop brake to make sure the brake is working for all 3 types of crane movement.